Good day to you, class. We're going to do some performance task in construction in geometry, and we're going to do it using papers and compass and straight edge. So let's begin. Let's proceed to our paperwork. All right, so we're going to do it over here. So we shall start doing angles. We shall draw an angle and copy it. Okay, so let's start with the initial side. Let's draw the terminal side over here. Okay, so we're going to copy this angle, or in other words, we're going to duplicate this. Here we're going to duplicate this. All right, so we begin by making the initial side over here. All right, and we're going to use now our compass and adjust it to a specific radius. Okay, so we're going to choose this size. And we're going to use the vertex for the angle that we're copying, okay? And we're going to draw an arc there. Okay, now let's go to our other angle and use one of the endpoints as the vertex, right? So we're going to start here and then draw the arc. Of course, without changing the radius of our compass. Okay, now we're going to adjust the radius of our compass, okay, in such a way that the intersection of the arc with the angle will be our distance. Okay, so we're going to adjust this, all right, so that the radius is of this length there. Okay, so that will be it, all right. So you can see the distance or the radius, okay, from this point up to the other point. So if we're going to put here some labels, let's call this vertex point O, and this point A, and this be our point B. Okay, now we adjusted our radius such that the distance from A and B is our radius. Okay, it's over here, there. All right, now we're going to our second angle, or our angle, and we shall make use of this point. We will call it our A prime. This vertex will be our O prime there. Okay, using the point A prime and without changing our radius here for our compass, let the A prime be our center point now for the compass, and then create an intersection with the arc there. Okay, now you're going to connect the O prime with this B prime there, and this will now be our new angle. So just be careful connecting the points and make sure you're hitting the point in precision, all right? There. And that is the angle constructed, and you will notice our angles are identical. Okay, and you can make use of a protractor to measure these two, and they will have to be very, very close in measurement. All right, so this is how to duplicate an angle. We shall be able to make use of the straight edge and our compass to make now perpendicular line from a point to a given line. Okay, the point is not on the line, of course. All right, so let us try that. Okay, let's say we draw a horizontal line. Okay, just a horizontal line. There's the horizontal line. Okay, now let's say we have a point not on the line. Okay, say over here. There. And we're going to draw a perpendicular line from this point to the given line. Okay, perpendicular means it's going to create a right angle with a given line. Okay, all right, so we're going to adjust our radius for the compass or compass radius in a way that it will intersect the line in two positions or in 2 points. Okay, so we're going to adjust this, all right, and then such that it will intersect, all right, our given line, okay, our given line in 2 points. All right, let's one here and another one over there. Okay, so we have now 2 points here on the line, and we shall name this point A and point B. There. Now, using these 2 points, we're going to draw 2 arcs intersecting below this line. Okay, below this line. So let us start with a B. This B point, okay, will be used, and let me just put it exactly at the intersection. All right, there. Now you're going to swing this to draw an arc, like that, and then proceed to the other point A, and then draw another arc which will intersect in the previous arc. There. Okay. Now we're going to connect 2 points. All right. Let's name this point, the given point. Let's have this our P, and we just created a point over here. We'll call it point Q. There. Now we're going to intersect P and Q, or just use it for a guide to construct a line segment or line perpendicular to our first line. Okay, so you will just put your straight edge and make sure you align the P and the Q. Okay, if your objective is to draw a complete line segment crossing the line, then you can do that. Or you can just draw the P and up to the given line there. Okay, and these 2 lines now are intersecting at right angles. Okay, so this is right angle here. All right, there. So this is how to draw a perpendicular line from a point not on the line. Okay, all right. We shall try to make another of this version, a given line, and this time the point is on the line. Okay, all right. So let us do that at the other page. All right. Let's start first a line segment, and then we shall draw a perpendicular line from one of the points. All right. So let's say, for example, this is our line segment, and let's say the point is on the line. There. Okay. Let's make it exaggerated point, a slightly larger one. All right. Okay. We shall draw now a perpendicular line to this line and through this point. Okay. All right, so what you need to do is simply make this point, the center point of your compass, and then make two arcs, all right, that intersects this line segment there, okay? All right, so what we just did is we used this our center point, and then we draw two arcs, and without changing the radius of the compass, we were able to draw two arcs intersecting the given line, all right, or line segment. All right, let's call this our point A. Let's call this our point B. Now, our objective is to draw a line, okay, perpendicular and through this point, okay? All right, so we're going to adjust our compass radius such that it is longer than the distance from the given point on the line to the B, okay? All right, so we're going to adjust it so that it's longer, okay? All right, there. Okay, and so we're going to draw arcs above this. So we start using the B point as our center, and then draw arc over here. And then use the other point A there. And then draw another arc intersecting the first arc there. Okay, now you can call this intersection point, let's say point P. And then connect now this given point on the line and the P. All right, and you shall be able to draw the perpendicular line. And that's it. All right. That should be a constructed line segment through our given point. Let's call this given point our point G there. And so this is actually the converse of the first one. The first example is a line and a point not on the line. We were able to draw a perpendicular line connecting the given line and the point not on the line. And this example is an example of a point on the given line. We are going to draw a perpendicular line through it. All right. Now, let us now construct a perpendicular bisector. Okay. We will have a line segment and then divide it exactly at the midpoint. Okay. Divide it exactly at the midpoint. So we're just going to make use the lower portion of this paper. And let's say we draw exactly 3 inches. Okay. 3 inches. All right. You can see it from our straight edge. Okay, this is about 3 inches, all right? Okay, this is about 3 inches. Now we're going to divide this exactly 1.5 inches, all right, on each side. So that means we're going to determine the very center point called midpoint, okay? All right, now we shall set our compass and make use of the endpoint. Let's call this point A, call this point B, all right? And we're going to divide this 3-inch line segment into two 1.5 segments, all right? Now we shall use the point B and use our center point of the compass there and create arc above this there. And then go to the other endpoint, A, use this as the center point and draw another arc there. Okay. Go back to point B and make another arc below. And then go back to point A and then make another arc intersecting the previous arc. Yeah. Now let's call these 2 points our point R and point T. There. Now connecting point R and T, will now draw your perpendicular bisector. It will divide your given segment into two equal parts. There. Okay. Now this point we will call O. There. And this is our midpoint O. All right. And this must be exactly at 1.5. There. So this is actually, yes, exactly at 1.5 there. All right. Okay. So that means we were able to pinpoint the midpoint. All right. That is point O. So this is how to construct a perpendicular bisector of a given segment. Okay. Now let's proceed to making equilateral triangles. Okay, we're going to use a circle and then draw the equilateral triangle inside the circle. Okay, so we're going to draw our circle first. All right, let's start with the circle. Okay, let me adjust the compass. All right. Okay, so we shall draw a circle. There. Okay, now we're going to detect the center. All right, the center looks like over here. There. Okay. And now we're going to draw a diameter, okay? Diameter, all right? A chord which passes to the center. A chord is a line segment, okay, whose endpoints are on the circle, okay? And a special chord is a diameter, okay? A diameter, all right. A diameter is a chord which includes the center point. All right, so this is our diameter there, okay? All right, now we're going to make use of one of the endpoints and then draw arcs on the circle that will become the vertices of the equilateral triangle. We're going to use the endpoints. All right, so let's name the upper endpoint of the diameter A and then the lower B, like this. And then we shall use the A as our top vertex, okay? We shall draw an equilateral triangle with the top vertex on point A. Now, without changing the radius of our compass, we're going to use the center point for point A there. And then, all right, we shall be able to swing this like this. All right. Okay. Now, we shall use the other endpoint B and create arcs there. All right. Now, if you want to use the 2 points below, you'll be able to construct an equilateral triangle with the top angle on top there. Okay. All right. So let's call this 2 lower points C and D there. Now, if you connect the, if you're going to connect now the points A, C, D, you're going to have your vertex on top. Okay. All right. However, if you want your triangle with a vertex pointing downwards at B, then you can use the other 2 points. Let's call it point E and F there. Okay. Again, if you were not able to follow the steps, we started with a circle, okay, and then we draw a vertical diameter, of course, passing to the center, and we were able to have endpoints at point A and point B. And then without changing the radius of the circle, okay, we created arcs using the point A, all right, to swing here, okay, so that we have that point E there, and to swing over there to have that point F, and then to draw the points C and D, we use the end point B of the diameter and then swing it over there and on the other side there, okay? All right. Now, let's choose an equilateral triangle whose apex is at A. So we're going to construct the triangle ACD, okay? All right, so we will connect A and D. So just be careful with your points, all right, there. And then let's now connect A and C. So this should be our side there. And then connecting now the C and the D. All right, this will now construct our equilateral triangle. There. So this is an equilateral triangle. That means angle ACD is 60. Okay, this is 60 degrees. And angle ADC is also 60. And of course, angle CAD is also 60, okay? So that means this is 30, 30. So in other words, this is 60 there. So we have an equilateral triangle. This is 60 degrees. This is also 60 degrees. And also this is 60 degrees there. All right, so I hope you were able to learn how to draw an equilateral triangle using a circle. Now we're going to draw a regular hexagon, okay, using the circle also. Okay, so we shall try to use the bottom part of the paper. We shall draw another circle and then construct the regular hexagon inside of this. All right, so let us adjust the compass, all right. All right, here comes the circle. We're going to draw the circle there. Okay, so we're going to determine the center point and draw a horizontal diameter. Okay, so we get our straight edge, okay, and draw a horizontal diameter there. Okay, let's label this as our point A and point B there. Now, using the point A and point B, we're going to draw 4 additional points on the circle, which will become the vertices of the hexagon. Without changing your compass radius, all right? Don't change it, all right? Start with A, use it at the center point of the compass, draw 2 arcs on each side there, okay? There, intersecting the circle. Now, you can call this your point C and point D there. Now, using the other end of the diameter AB, you can now use this as your center point now for your compass, and then draw 2 more points, okay, using the arcs there. Okay, 1 arc over here and 1 arc over there. All right, this is now our point E and point F there. Okay, so we shall now just connect A and then C, C and F and B, B and E and D, and back to A. We will now have our regular hexagon, okay? All right, so we will just connect this, all right? Let's just connect first A and C. There. We connect now C and F. And then we will now connect F and B. There. So we have the three sides of the hexagon. We can now continue with B and E. We set our straight edge so that we will catch the points precisely at the intersections there. Okay, and now we're doing E and D side. There. And then finally, the closing side will be the AD, back to point A. So this is now our sixth side. All right, there. So we have our regular hexagon inside the circle. Okay, the regular hexagon. Now, one thing about the hexagon, you can actually create 6 equilateral triangles inside of this. Okay, we shall connect by looking at the point F and D. If you connect this, and you'll be able to see how it's going to be. All right, passing to the center, of course. Let me just adjust it. All right, so that it will be precise at the center there. Okay, and let's have the connection from point C and E, okay, over here. There. And you can see the 6 equilateral triangles, which are the components of the regular hexagon. And so we have a regular hexagon now. You can see ACFBED. That's the regular hexagon. And these are all composed of the 6 equilateral triangles. All right. So this is how to do equilateral triangles and hexagon, regular hexagon. Well, when we say regular hexagon, that means the the interior angle is constant at 120. So this is 120 there. That's 120. And all the other angles here, all the other angles is 120 there. That's 120 there. That's why it is called a regular hexagon there. And also this is regular hexagon. Each interior angle measures 120. All right, so that's it. We shall learn how to draw an angle bisector from a given angle, okay? All right, so this is very simple. Let's start with an angle, and then we shall divide the angle into 2 equal angles, okay? So let's say, for example, we have an angle, all right? An ordinary simple angle, okay? We will just draw the starting side called initial side, and let's have the terminal side over here. All right, let's have it somewhere here. There. Okay. Now we're going to split this angle, all right, into 2 so that we will have 2 congruent angles, all right. We will have to draw the angle bisector, that particular ray that divides the angle to 2 equal angles. All right, this is how to do it. Your angle is right here. Let's call the vertex O there. And then adjust your compass such that it will use the center point at the vertex O and then drawing 2 arcs on each side of the angle. So 1 over here and 1 over there. Okay? All right. Doing this, you're going to produce 2 points, and we'll call these 2 points Let's call this point A and point B there. All right, without changing your radius or compass radius, without changing it, all right, use the center point for A there of your compass. And then at the interior of the angle, okay, interior of the angle, create an arc over here, all right, there. And then using now the point B, all right, create another arc intersecting the previous arc there. Okay, now the intersection of these two drawn arcs, we will call it, say, point C, okay, over here, all right, this point now, all right, this point, that is point C. We're now going to connect point C and the vertex O, okay, and we shall be able to draw our angle bisector, that particular ray that divides the angle into two equal angles. There, okay, all right. Now, notice this angle is equal to this angle there. Okay, so this is how to do your angle bisector. So this is how to split a given angle into two equal angles. So what do we mean by this? Angle AOC, the measure of angle AOC must be equal numerically to the measure of the angle COB there. Okay, and this is it. I hope you were able to learn something about constructions in geometry, and you can do practice at home using a compass and a ruler, using our examples. All right, so this will be all for now, and see you again next time. Bye-bye.